Okay, so I'm gonna go ahead and finish up your guys' study guide today. I got through about half of it, and I'm gonna do the other half of the odd problems now. And then your guys' job would be to finish up the even ones. So number 11. The problem is 5x to the 1/3 power, and they just want us to rewrite it in radical form. When you rewrite these things in radical form, the bottom number goes here, the top number goes here, and the inside goes here. It's pretty straightforward. That's it. Pretty easy, right? Don't miss that one. Another thing that's going to be on there for number 13 is the cube root of negative 375 x to the 8th power. Okay, so first of all, when you're doing cube roots and you have a negative inside, what you do is you just take the negative out, okay? Now, if it's a square root, you don't take the negative out. What you do is you replace it with an I. It's an imaginary number. But with cube roots, you don't get i's. You just get a negative on the outside. The next thing that we're going to do is we're going to go ahead and break this down. I kind of did the work earlier, so I'm going to be able to get this a little bit faster. But if we break this down, we get the following. So we have this. We have 3 5s, a 3, and then there's also 8 x's in there. Now, if you could do this without showing the work, it's pretty easy if you can do some mental math, but if not, I like to write it all out in case people are struggling. So we're looking for the cube root, so that means we're looking for groups of 3 things that are the same. So there's a group of 3. So for every group of 3, we're going to cross it off, and we're going to write one number on the outside of the cube root like that. Here's another one. So I can write it out there and cross it off. And there's another one. These ones don't have enough to give. And we don't want to forget our negative either, by the way. So what I've got left on the inside is 3 and 2 x's. And then we can simplify this. X times x is x squared. So we end up with 5x squared times the cube root of 3x squared. So that's how we do roots, okay? Let's take a look at another one here. Number 15. It's really just another example. There's really not much different about it. 256 into the 7th power. All right, so notice the 6th root. So we're looking for groups of 6 instead of groups of 3 this time. So we want to break this down. So just because I know my times table's pretty good, I'm pretty sure that comes out to be 16 times 16. And then 16 is 4 and 4. And then 4 is 2 and 2. So basically, we just end up with a whole bunch of 2's. So 1, 2, 3, 4, 5, 6, 7, 8 2's. And 7 n's. Now we're looking for groups of 6 that are the same. So let's circle 6 of these 2's here. And for every group of 6, we can cross off the group and write that number on the outside. Same thing here. We got 6 n's, so I can take an n out. And now on the inside, I've got 2 2's and an n, which is 4n. And there's that one. So that's roots. Okay, Next type of question, number 17. And by the way, anytime you want to stop the video and do the next number right after it, like after 13, if you want to do 14, after 15, you want to do 16, it'd be good because these problems are kind of like matched. So like number 14 is and 16 are kind of like 13 and 15, and 18 is kind of like 17. So that way you can practice it that way you can. It's up to you however you want to do it. All right, so number 17, what we're doing is we're solving an equation. Okay, so for this problem, what we want to do is we want to get this piece here by itself first. So I need to get rid of that 9. Now, how do you get rid of the 9? You're going to divide it because this negative 9 is multiplying the square root. So to get rid of it, we divide both sides by a negative 9. Now that we've got the square root by itself, I want to get rid of that square root. The way that you get rid of a square root is you square it, raise it to the second power. But if we do it to one side, we also have to do it to the other, right? So 9 squared is 81. And then this cancels out the root, so we're left with that. Okay. The last thing we need to do is just add 9 to both sides. And we end up with 90 as our final answer. Okay. Now on number 18, I'm not going to do it completely for you. I want you guys to do most of the work, but it's a little bit different from this one, so I will give you a little bit of a heads up about it. On number 18, we have the square root of 5 minus 2n minus 3 equals 2. Now here's what's different about it. On my example over here, I divided that number to get the square root by itself, right? On this one, what would I do to get the square root by itself? Well, this time, I'm not multiplying this square root by anything. I'm subtracting from it a 3. So what's the opposite of subtracting 3? It's adding 3. So I don't want you to think it's always going to be like the one I had over there. It's not always division. And it's not always addition. It just depends on the problem. Over here, we divide because it was being multiplied. Over here, we add because it's being subtracted. Likewise, if it was being added, we would subtract and vice versa. So that's 18. All right, last thing that we're going to go over here is for numbers 19 and 21. Okay, number 19. We're being asked to graph. It's a square root function. All right, so when you're graphing square root functions, these two numbers here make up your starting point. I want you guys to notice also the sign is opposite on the h. This says minus h, but this is a positive h. So you change the sign of this number. You don't change the sign of this one. It's a positive k, it's a positive k. So you change the h, but you don't change the k. That's your starting point when you're graphing these. Now the next thing that we're going to do is we're going to remember a little chart that I gave you, and if you're going to use notes on this test tomorrow, you might want to write this down on your study guide, or just bring your notes with you. It's in there somewhere. The direction this graph goes depends on two things. It depends on whether A is positive or negative. It also depends on whether B is positive or negative. Okay? When A is positive and B is positive, the starting point is here, HK, and it goes up like that. That's what it looks like. That's the graph. It makes like a little curve. When A is negative, what that means is so basically, let me summarize a little bit. This tells you whether you're going up or down. This number tells you whether you're going left or right. So when A is positive, the graph goes up. When A is negative, the graph goes down. B tells you whether it's going left or right. So when B is positive, it's going right, but when it's negative, we go left. So for this one, the graph's going down and right. So if we have our starting point here, it would go down and right. But it would have the same basic shape as this one, just like it's been flipped upside down. This one here, the graph is going up but left. So that would look like this. And for this last one here, it's going down and left, so that would look like this. Okay? So that's how you graph square root functions. So let's do this one here. The first thing that we're going to do is, I'm going to put a 1 there so we know that our B value is 1. So my A is 2, my B is 1, my H is this number here, and my K is this number here. So remember, our starting point is going to be these two numbers, the H and the K, but for the H, we're going to change the sign, and for the K, we won't. So that's my starting point. So when I'm graphing this, that's where I start, at 2, 1. Now we look at these two numbers, the A and the B. Notice my A is negative, but my B is positive. So when you have a negative A and a positive B, the graph looks like this. So it's going to go down and right. And that's it. That's the graph. Okay, one more problem. Number 21. So we have the cube root of negative x plus 4. This thing's missing a lot of numbers. Now, but before we get into graphing it, notice it's a cube root instead of a square root. Everything is the same over here except for a little bit of a difference, one little difference. Here it is. So we're going to put a 3 there now. That's still going to be our starting point. But here's what's different. In the graph, all of these kind of get a reflected image added to it. So for instance, for this one, it's going to look like this now if it's a cube root. For this one, it's going to look like this. For this one, it's going to look like this. And when we were in class, when we learned it initially, we said it gets a tail. It's the same thing as a square root function, but with a tail. Okay? So rules are pretty much the same, but once again, you might want to add that in your notes if you're going to use your notes tomorrow. Now, let's go ahead and take a look at this. So notice that we don't have a number in front of the cube root. When that happens, it means it's a 1. Okay? Also, we don't have a b. When that, well, we kind of do. It's a negative, but the number would be negative 1. So my b is negative 1. We also don't have a minus h. Now, h is different. When h is missing, it's a 0. Okay? The same thing applies if k is missing. If k is missing, that's also a 0. Okay? But now we have all the numbers there that we need. My starting point is going to be 0, 4. I've got a positive a and a negative b. Positive a and negative b looks like this shape. Okay? So it's going to look like this. It's going to go up and left, but don't forget to give it a tail. There we go. And that's it. So that's graphing cube roots. And that's the end of our video. So hopefully that's helpful. We'll see you guys tomorrow. Make sure you guys do the even ones. And that's your homework for tonight.